Yesterday, my screen is recorded only for 19 minutes. Sumant.
It was only the first part. I think it was
Yeah,
only
only first part, man. I was shocked. Yesterday night, I was trying to record once again, but I was tired, so I did not do it. Okay, to understand the system information, we have very handful of commands. Okay, so you can easily understand it. So to display the system information, you need to type uname hyphen a. Okay, so this will give you the system information Linux CentOS 5.1 point this thing. Okay, so to understand the system information, you can use this command. And host name, to understand the host name itself is the command. So what's the host name? It's a CentOS 7. Okay, so now I'm using the root directory. So so when I have hundreds of users uh, under the root directory, sometimes I may not know which user I'm currently on. So who am I is a command which helps you to understand the current user. It's a root user. So let us switch to uh, Sumant. Okay, now we are in Sumant. Who am I? So I'm Sumant. Okay, so we just now exited from our user Sumant, and to display the current date and time, just the date and time. So it is currently in MDT. Okay, so it's not in our system time or in IST. Okay, so uptime, since how long the system is up? Um, okay, 23 5:17, up 4 minutes. Okay, 4 minutes. I we just booted the CentOS, so it is showing 4 minutes. Okay, so then to display the memory usage, free is the command. When we say hyphen h, it's the human readable. Okay, so these options after the command, which you need to understand, memorize. So many places we'll use I, V, H. Okay, when we say I, it is install. V, verbose in the sense, for if you are using many commands to install something, so it will display the information. Okay, verbose. And then if we are using h indicates the human readable format. So when I simply type free, so uh, I think this is showing in kbs, kilobytes. Okay, so free hyphen h human readable, it will it is showing in gb. Okay, so the total memory is 1.6 gb and used is 258 memories, m megabyte. So 1.2 gb is free and shared buffered cache available. Okay, so these are the swap memories. Okay, so this is how you will see how much memory has been utilized free and how much is in total. So df, disk fragmentation, it will show the disk space usage. Okay, so free, it is showing the memory usage and total memory. And df disk, if you have any drives, okay, or disk, so that will show the space usage. So df, again, human readable format. Okay, so now we have these many file systems. Okay, so for temper dev mapper, okay, 4 MB, 820 MB. So how much has been used. Okay, so go through the file system. Yesterday we have seen the overview of the file system. So once you learn all those file system, you will understand what all these. Okay, so these are just the disk spaces. So clear is the command to clear the screen. So now we need to understand the current running processes. So I need the list of current running processes which are running in my system. So PS, okay. When I type PS, so these are the current running processes. So we are in sudo. So sudo application is up, bash is up, and then PS. We just ran this PS, so PS is up. So this, it all has the process ID, so you can use this process ID even to uh, terminate or something like that. Okay, so let's take this particular process ID and kill it. Okay, kill. Okay, let's not kill that one. Will, because if we run once again, so top is the command. Okay, it is used to view the real-time usage of a processes. Okay, say currently real-time and dynamic usage of a uses of a I mean usage of a process, right? Say sometimes uh, some process may take some CPU utilization like zero point 0.2. Sometimes it will not, so it will show the real-time progress, okay, of the process usage. So we are in root. Sometimes it is taking more and sometimes it is taking less. Sorry, the top command which we just ran. Okay. Mm, okay. So control C is to terminate the cancel the current running process. And if some command is stuck, then control Z is to suspend the particular process, particular command that is currently under progress. Okay. Um, okay. PS. So do we have Chrome installed? I think we don't have any process installed only here.
We installed Google first
Google. Okay. Mm,
with Yum.
okay. Okay. Oh, I think we installed in your username, I guess, not in the root.
Yes, I guess.
Okay. Anyways, we'll switch to Sumant and Google Chrome. Here also command not found. Okay, there is a command suggested. We'll try this command. Command not found. Okay, then let's do one thing. PS, what is there? Okay, now we are not in root, so the root is not showing up here. Mhm. Top command, process ID, pull or queue, system D. We'll do one thing. We'll kill this process. VM tool SD 930. Okay, I don't know what it is going to do. Kill process ID 46. Okay, let's say 46. Yeah, it is a system file. It is not allowing us to terminate that. Okay, we'll do one thing. We'll create a separate process, but kill. If you give process ID any of the user uh, user applications, we can use this particular command to terminate it. Okay, just note it down.
Yes, sir.
Okay. So now if config command not found. Okay, if config, I think it is for the um, this one, Mac OS. So IP ADDR. So here you will find the information about your IP. Okay, so you have your loopback 00. So inet. So this should be your router IP. Okay, this should be your system IP, I guess, and broadcasting IP. So using IP address ADDR, you will be able to what in Linux you will be able to identify your IP address details. So ping, so Control C is to cancel the running command. Netstat. Um, have you ever used Netstat, guys?
No, no, sir. Let's start. I need to.
We haven't used. Okay, I think we need to install Netstat.
It's a package.
Yeah, I have never used.
In Windows, it will work, sir. Let's start.
Sorry.
Windows, let's start will work, sir.
In Windows, okay, okay.
Ah,
Do you guys know how to read this? Because I'm not sure. This is the first time I'm using this command.
So that is what our connections are established. We'll get to know, sir.
Yeah.
Now see, set of SSH and TCP connection is established, and this still says CentOS 39728 which is typing rate. We'll get to know what connections are established.
Okay. So this is the
Or you can use an expat minus
let's start minus
A
A.
to
Okay.
see. We will see what numbers also.
Okay. Okay. So we'll see the listening ports, right? Which ports are listening
Yes, sir.
to our broadcasting. Okay. Hyphen A. Just A or hyphen A, man.
That all is sir.
So these are established TCP, UDP connections, and these are the listening ports. Okay.
If you open any application, you will get new connections.
Okay. 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 Fine. So SS. Then next thing is SSH. We know the SSH, like secure shell. So we'll establish a connection to the cloud or remote server through SSH. Okay. So right now we did a Vagrant SSH, but when we spin up an instance and taking the cloud instance in CLI, we'll see that in detail. Okay. So generally SSH taking SSH, we need to type SSH username and the host name. Okay. Username at host name. So this is the uh, syntax. Okay. Note this down. So with this, so we are completing the Ubuntu basic commands. Okay. So what we have seen is from yesterday till today. Now we have seen the navigations command category and file manipulation category, system information, package management. So package management. Uh, there are several package managers are there. One is apt, apt, and yum. So apt is also a package manager. Yum is also a package manager. So by using yum, we installed netstat here today. So same we'll try to install using apt in the further topics. Okay. So then process management command uh, to use the current running processes, top commands, kill commands, which we have seen. Networking user permissions, and have we seen anything else? So mostly whatever there is in this particular Linux hand guide we have seen. Okay, and then Linux commands. Linux Ubuntu cheat sheet I have given you the access. This one. So this one is what we have seen today. ChatGPT. Okay. Now, shall we get into Git? I think now Prem is expert in Git. He will only explain us.
I know basics.
Okay. Okay, man. So Git. Uh, so looking at the definition, Git is a distributed version control system widely used in software development. It allows developer to track uh, changes to code over time, collaborate on projects, and manage different versions of their work. Essentially, it's a tool that helps manage code and its evolution, particularly when multiple programs are working on the same project. Okay, so this is the definition to Git, and what we are going to learn is why version control system. So Git is one of the version control system, source code manager management tool. uh, what is VCS, I mean version control system, and why version control system. Okay, and centralized and distributed version control system. So what is Git? Git repository, versioning with Git, and some of the concepts and commands. How to log in using SSH to the Git, and Git Copilot. If you log into Git, there is a Copilot. So we'll learn all these things. Okay. So, what is a version control system? Version control system, also known as source control or revision control, it's a software tool that tracks and manages changes to files, especially source code. So, over time, it allows user to revert to the previous versions, compare changes, and collaborate effectively, making it crucial for software development and other projects involving multiple revisions. Okay, so generally version control, it allows us to uh, compare the changes between the versions, and it helps us to revert or roll back to the previous version if something goes or went wrong, and effectively and efficiently manage our source code. Okay, so what are the key benefit? So it enables the team to work together on the same project without overwriting each other's work. Okay, history and rollback provides a complete history of changes, allowing you to revert to the previous version if needed. Error recovery makes it easier to identify and fix by comparing different versions. Organization like keeps your project organized and prevent chaos when working on multiple versions. So to give you a easy picture, let us say you have multiple folders on your system. Okay, so folder 1 is for Sumant, folder 2 is for Prime, folder 3 is for me. Okay, so these folders are given to us to work on our project. So what we will do is we will create a subfolder and do whatever that we wanted to do and move it to the uh, that particular folder given by the organization. So from there, what project managers are they have is they have a main folder where all the projects that we worked will be what committed and stored there. Okay, so you can compare this with folders. Okay, though we call it as repository, version control, branch, master branch, branch. uh, so you can correlate this with the folders. Okay, so far make sense, guys? Understood?
Yes, sir.
Okay, so let us see what is localized version control system. So It allows a developer to record different version of their code, collaborate effectively, and easily revert. Okay, this is just a definition. So, so localized version control system. Each developer has local database on their machine. Changes are saved and managed locally. Okay, not shared with others automatically. So changes are saved and managed locally. So this is suitable for individual developers or simple project. Okay, so so this is your file. This is your local computer. You have a local repo, also a local branch, adding to that. So this is your file. So what are you going? What you do is you are making changes to your file and uh, committing it to your local repository. So first commit, it will save us a first version one, and after some time you make another changes and do another commit. Okay, that will be stored as a second version, and after some time you are going to make some more modification or add more lines to your existing code or existing content, so that will be stored as a version 3. So like this it will store all of your changes in a version. Okay, so benefits: simple and fast, no internet or server needed because you are going to make changes in your own system, own local repository. So uh, demerits or cons is collaboration is difficult, risk of data loss if local machine fails. Okay, so all these changes and commits are happening in your local repository. So to mitigate these cons, the centralized repository is there. So centralized repository, there is a central server that holds the complete code base. Okay, from your local repository, you are committing to the centralized repository. Okay, so developers pull the code and push the commit changes to the central repository. Say this is your workstation PC or local PC, you are committing it to the central repository, which is server. Okay, and any changes that are being done there can be pulled to your local machine. Okay, understood, guys?
Yes, sir.
Okay, so this is suitable for multiple people working on a single project or a collaborative project. So pros, I mean benefits is always easier collaboration. Backup is available on a central server. So server going down, it's very rare, but sometimes if server goes down or if server is not reachable, then committing the code is a bit difficult. Uh, okay, so that is the disadvantages. So traditional versus a distributed version control system. Okay, so traditionally, client doesn't have a repo. Okay, so whatever the changes that you do here, so that is traditionally stored in the server. Only server has a repo. Okay, but in the distributed thing, client, even developers have a repo. Okay, and in turn server also have a repo. Okay, so that the code is stored in multiple locations. So any data loss, any corruption, or uh, any downtime to the server will not be impacted. It will not be impacted. Production will not be impacted. Okay, so this is the difference between traditional version control and the distributed version control. So traditional, only server has a separate repo, but here all the users client machine has the repo as well. So distributed version control system. Um, yeah. So clone and pull local. Okay. So working PC number one, like this is the local PC. and from your local PC you are committing to the repository, local repository. Okay, and from local repository you are making the changes to the server. Okay, so at the same time you can make changes directly on the server itself, and that can be pulled to your local repository, and this can be pulled back to your working machine. That means your machine.
So this is direct change in the server repository. So what is it?
Yeah, so yeah, it happens in two ways, Sumant. One, uh, you are doing changes in your local machine and you do a commit to your local repository. Okay, so from local repository you do a commit push to the server. Okay, so whatever the changes you did in your local machine, it gets committed to the server. Okay, that is one way of doing it. And the second way of doing it is you can go to the server and do the modification or changes in the server itself, which in turn can be requested as a pull request, and that changes you made in the server will get reflected in your local machine.
Okay.
Understood?
Yeah, got it.
So it happens vice versa, both the ways. Okay, so this is very important, you need to understand this. So how Git actually works. So this is your working directory, which is your machine PC. Okay, from here you are adding your changes to the staging area by using git add command. Okay, just we are adding to the staging area. So staging area is the intermediate area between stage between your local repo as well as your working directory. So that means you are saying you are ready to push this particular code, and once the code reaches the staging area, after you do a commit, it will go and merge in the local repository. Okay, so from the local repository, uh, when you push it to the remote repository, it will go and merge with the uh, what remote repository, that means the server. So this is the way how git actually works. Okay, working stage 1 working your working directory, stage 2 staging area, stage 3 local repository, stage 4 remote repository, which is server. So any changes made here, or if a new user who joins in your in your team, he doesn't have a local repository at all. He has to rely on the remote repository. He wants to create a or a clone a repository in his device. So at that time, what he will do is he will do a pull request or a clone request and clone the entire repository in his local system. So when you do git pull command, any changes you made directly in this particular remote repository will get pulled to your directory, working directory. Okay, makes sense, guys.
Oh yes. Like fetch is also the same thing.
Fetch is also the same thing. Fetch merge is also the same thing. See, this fetch is from your remote repository to your local repository. You are doing git fetch. Okay, and from local repository to your working directory, git merge. Okay, we'll look into the command. This is just for your basic understanding. A lot of commands are there. We'll look into it directly.
Okay.
And when you do git pull, it will pull the changes directly from remote repository to the working directory. Okay, so okay, so what if uh, you are making a changes but you don't want to do it, but you need to pull it back. You have made some minor mistake that is going to um, what that is going to make some disruption to the code base. So at that time, what you can do is, say if you made only the changes in your working directory, you can roll it back, okay, by using git checkout. Okay. So after you move the cases, I mean, after you move the according to the staging area, you can restore it from the staging area. Okay. uh, what if you have already committed the changes to the local repository? So at this stage you can revert the changes. Okay. So, and what if you have made the changes, what um, changes, and you don't want to uh, create another commit. Okay. So when you say git revert, so it will create another commit to the uh, this repository, like this particular code base or code changes have been reverted. Okay. But you don't want to uh, make another commit. Instead you want to revert back. Okay. Revert back to the previous commit. So at that time you can use reset, git reset, to reset to the previous version, so that the new line item will not be created there. Okay. So we'll look into it practically. Okay. So ideally, these are the four stages. This is your working directory. From here you can make the changes to the staging area. Bring your changes to the staging area, and from staging area you can commit it to the local repository. From local repository you can push it to the server. Okay. So at any stages, if you feel like this code is not going to work, or you need to make some more modification, you can revert it back. So every stages it is called as reverting back the changes, called as a different, using a different name. We call this by using a different name. So reverting it back from the working directory, we call it as checkout. Here it is restored, and here it is either revert or reset. Okay. So both the scenarios, there are two scenarios. One scenario is, uh, after reverting this, it will create one more versioning, like line item. If you don't want that, you should go for the reset, which will not create another line item, but it will just roll back to the previous commit. You guys with me? Understood? Not understood? Or did I confuse you guys?
No, sir, I got it. No, sir. Understood, sir.
Understood, right? Okay.
Sir, for the checkout is something that we have to like go back to the previous branches, right? That is why we use checkout.
No, checkout is, um, okay. So checkout is, from your working directory, you will move the codes to the staging area. Okay. But you made the changes here, but you don't want that to get to the staging area. So what you will do is, you will do the checkout, so that the changes that you made in your working directory will not get changed. It will get reverted.
Okay, the modification made in
Yes.
file.
Yeah. Yeah.
Okay, got it.
Okay. Because why every stages have different restoration method is, so a fast moving organization, or develop an organization who is developing their software in aggressive way, they automate everything. Okay. So what Jenkins do is, it will read the code every now and then. So whatever the changes you are making, it will go and start its build, continuous integration and continuous build. Okay. So we need to be very careful at different stages. We need to use different commands to restore the files.
Okay.
Okay.
Yeah.
Okay. Local repo setup, remote repo setup, git branches, staging. Okay, so let's let's understand the difference between branches and staging. Okay, so Git branch, a branch is a separate line of development within a repository. Think of it as a parallel workspace where you can work on changes, features, bug fixes, or experiment without affecting the project main code base. So the repository which we are going to create, we will create a branch also, which is like a subfolder. So whatever the changes we are going to make, we are going to make it in the branch, then move it to the our local repository. From there, we will do the staging and committing and all. Okay. So what is staging? Staging in GitHub is referred to as the staging area, which is also called as index, which is a crucial intermediate step in Git's workflow. The staging area acts as a preparation or holding zone between your working directory and the repository. So now you guys understand the difference, right? So staging is the holding area, holding zone between your working directory and the repository. When you modify files, that changes remains in your working directory by running git add okay file name. You place specific changes into the staging area, telling it exactly which changes you want to include in your next commit. Okay. So branching and staging are two different things. So branching is like creating a subdirectory, a subfolder for your main working folder, and staging is the intermediate stage between your working directory and the repository. Okay. So let's open the terminal. Let me exit. So now Linux will not come into picture. Now we need to go into our system. Okay. Exit, exit, exit. Okay. Okay. So now what we need to do is we need let us create a separate folder where we need to create our local repository. So let me do one thing. Let me. I already have one. Um, so just go and create in your machines, guys. I have it in the.
So this is not in a VM, right?
This is not
It's
in a VM. It is in on your local system.
sir, I'm using Git Bash. Is it okay if I use Git Bash?
Yeah, anything is fine, but I suggest you to use um
Normal terminal.
normal CLI or shell itself.
Sure, I'll use PowerShell itself.
Yeah, PowerShell, that is better. So what I did was I created a folder July 2025. Okay, within that folder, so I have a folder called Gautam code. Okay, so we just need to create a folder, a directory in our system where we are going to manage that repository. Once that is done, let me know, guys.
Yes, sir, I have done.
Prem.
So no, sir. Like you explain, sir, because I was recording.
Oh, you're recording the session. Okay.
Ah,
Okay.
sure.
Anyways, I will share you the list of commands after the session. You can try it out. Okay. So what we need to do is git init. Okay. So this will create a repository under this particular directory. Okay. So I already have it installed. So after installing, if you type ls hyphen a, so you will see the dot git. I mean dot git. So this git init. So this will create a master repository under this particular folder. So after it has been created, you will see the dot git. So if you have this, your master repository has been created.
So for using ls hyphen a, should we any do any package should be installed?
No, I don't think so. I think it's a system inbuilt command. You should get it. Is there any error that you're getting?
Yeah, I'm getting that. That
Okay.
parameter cannot be proceed because of parameter a because I'm using hyphen a.
Okay. Can you try installing it? If Because if you normally type just the list command, you won't see this.
Okay, so I'll do it later on. That's fine. For now, I'll be using it.
Okay. Yeah, whatever works for you, use it.
Okay.
Okay. So I'll tell you. So git add space dot. Okay. So this will take the uh, files to the staging environment. Okay. So git status. So right now I have all the changes committed to the repository. I don't have any files to take it to the staging environment. So what I'm going to do is I'm going to edit any of these files. Okay. So what you can do is you create some directories and folders. Okay. Say right now I only have code 1, code 2, code 3. These are directories, and these IDs, these are key which I have created to sync this particular machine with the uh, remote repository. Okay, so that we will see like in a moment. So function.py, loop.py, variable.py. So these are something which I have created. Okay, so all these are already there in the remote repository. So now what I'm going to do is I'm going to create a another file, touch um, function variable loop. um, give me any of the uh, development concept, man. Function loop variable condition, right? Condition dot py. Okay, so now I have one more file called condition dot py. Okay, so vim condition dot py. So I'm going to make some changes. uh, okay, insert mode. If a is greater than b, then uh, c is equal to 10. Okay, I'm just giving some random thing. So escape colon wq. Okay, so now we have made some changes in this condition.py file. Okay, now git status. Okay, now it is giving me untracked files, right? So use git add to include in what will be committed. Okay, okay, so now I have made a changes in the existing file. So this is saying untracked files. That means there are some changes. This is the new file, or some changes happened in this file. So nothing added to the commit, but untracked files present. Use git to track. Now what I'm going to do, I'm going to use git. Okay, add. If you use only dot, it will come. It will commit all the files, or I mean all the files and folders which are available in this particular repository. So now I'm going to add this particular file name. So the changes uh, will take place only for this particular file. Okay, so now I added this particular file to the staging area. So now git status. Okay, so it is in staging area, that is why it is showing unstage. So from this area I'm going to push it to the commit. But before that, changes to be committed. If I want to restore it from here, I need to use this particular command to restore, because this particular changes already we moved it to the staging area. Okay, so now I need to commit this. Git commit hyphen m. So we need to give the name for this particular change. So new file condition. Okay, so one file changed. So I added three lines, so there are three insertion in that particular file. Okay, so create mod. Okay, conditions.py. Now let's say git status. Git status. Okay, so now there is nothing is left to commit. Okay, so this is how we created a file in our local repository. um, okay, and then we moved it to the staging area. From staging area we moved it to the what to the local master repository. Understood, guys?
Okay.
Make sense?
Good. Yeah.
Okay. So you can use git log to understand what changes we have made. Okay, so this will give you a big explanation. So let's do one thing. So git log hyphen hyphen one line. So if you give this um, new file, see the commit which we just made is added as a line item here. Okay, it got logged here. This is the commit id, and now the code, the condition, the file is in the head branch. Okay, head or master both are same. So where it comes from, it comes from the code banks to the head. New, the commit name which we have given is the new file condition, so that is here. Okay, so this is how you will identify the number of commits that you made to the master branch. Okay, and if you want to revert it back, you need to understand which commit you want to revert. Say for example, after adding this particular file, my code base got disrupted, or some error has popped up. So instead of taking some risk and fixing the particular code, taking time, which takes time to fix the code, we can revert it to the previous commit. Okay, so this is where those uh, that what checkout, revert, restoration commands will come into picture, which we will look into in some time. Okay, so now what we need to do is we are going to create a remote repository. Okay, and uh, push this code to the remote repository. So for what we did, we moved, we created files and folders in our local machine and moved it to our local repository. Okay, local master repository. So now we are going to move this code to the remote repository. Okay, make sense, guys? Am I blabbering something?
No, so got it.
Okay. Okay. So I already have a repository, which this one we created already. Okay. So what we need to do is we need to create a what uh, a repository, same name like that of our local machine. Okay, in order to sync it properly. So there is a command to create a username and email address for our local repository. We need to create that as well. So here repository, go to the repository and create a new repository. Okay, and give the repository name same as what the folder name which you have created in your local machine. Okay, so keep it private, because keeping it in public, anybody can access your repository. But for now, let us keep it in private itself. And after you create a repository, it will create it. So I already have a repository uh, called July 2025. Okay, so in that, what I did, I already uh, committed from my local machine to here. I already committed the changes till this file. So today we have created a condition.py file. So that one we will move it to here. Okay, that we will commit it from our local repository to the remote repository. Okay.
Yeah. So we can create a number of branches and we still
Yeah, yeah, n number of branches. So when we need to be more careful when we are mentioning branches repository, local repository, remote repository. Okay, so branches, yes, you can create a number of branches.
Okay. So this local repository and the remote repository should be in the same way, same name.
Same name, yeah, it should be in the same name. Else if you are creating it in using a different name, you have to generate key and let your local repository as well as the remote repository know, yeah, this is the file, which I mean this is the folder which you need to sync. If it is under the same name, it is all fine, you don't need to create any keys. Okay, there is a
Okay.
catch here.
Okay.
Okay, because what mistake that I did is I created a local repository under this name Gautam code, but here I created July 2025. Okay, so this has created a confusion, and then I took, I mean, troubleshooting. End of the day, we are from support team. So what I did, I just generated the key and went to setting and added a key there, as well as in my local machine I added the key, just letting them know, okay, both are same, you can sync.
Okay.
SSH is different. I'll explain that. Not now. That doesn't work out now. So now see guys, function ID. Yeah, yeah. We'll come to that. So function ID loop variable. These files are already there. Okay. ls. So condition ID function loop variables. Okay. These files are already there. So what is not there? Condition is not there in the remote repository. Okay. So now what are we going to do is we are going to uh, push the commit from our local repository to the remote repository. Git push origin main. Everything is up to date. Okay. 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 Branch main setup to track origin main. Everything up to date. Mm, okay. Pull is from we are pulling the what changes from the remote repository to the yeah. Okay, this is the command. Um, it worked yesterday. I don't know why it is not working today. Okay, let us ask
Instead of main, you can give master ref.
master.
Yeah, we don't have
No,
that.
only main is there. Master is not there.
Sir, can you give git remote version hyphen v,
Sorry, git
a remote
remote
hyphen v?
hyphen v. What is this command?
I mean whether remote is linked or normal one.
So check status whether it is in local repo, whether in local repo.
Git plus committed.
Local commit it is made. It's all up to date. Yes, sir. Nothing to commit. Working tree is clean. So we have condition py also here. Gautam code. Okay. Hmm, okay. Git push only we did, right? Git
Yes,
push.
sir.
We'll try once again. Git push main.
So hyphen u.
Oh, hyphen u version. Uh, Instead of main, we'll give it as head. We'll try. Okay. Oh boy. Okay. This is why it is very important because I created a branch and I did all the changes in the branch, not in the uh, main. See, yeah, it is correct. It got applied, but it applied in. Yeah, so I did all the changes in the branch, not in the main folder. Okay.
So now we have to merge to the master branch.
Main branch, yes. Uh, okay, give me 1 minute. I need to log in. Okay. So this command is used to push the code from your branch to the repository. Okay. Branch main setup to track origin main, everything is up to date. So here guys, this is the structure, tree structure. Okay, this main is the repository that we created, and code banks is the uh, branch which I created. Okay, so that I don't want to make any changes in my main branch. Instead of that, I will do it in the uh, repository. I mean, not repository, branches. From branch, what I will do, I will merge it with the main, and from main, I will merge it. I mean, commit it with the uh, this repository, local repository, and from local repository, I will merge it with the uh, this thing, uh, remote repository.
Sir, explain again, sir, how you did commit from branch.
Yeah, yeah. 1 minute. Hmm. It is not still reflecting in the main. Um,
For the main thing, we have to like merge, no, sir, the main branch. I mean, currently you're doing it in the branch.
yeah, so by providing this command, git push origin code banks, it will go and merge it in the main branch. Okay,
Okay.
or git push you. Branch main set up to track origin main, everything up to date. Okay. Um, okay, now we are in main branch. Git switch main. Um, okay, let's how to move files from branches to main repo. Okay, guys, this one I'll just go through it and get back. Note this down. But right now I'm mm, its status. Okay. So what we did is I created the condition file in the branch, not in the repository. Okay. So there is one command which is there to move the files from branches to the repository. So which I will investigate and I'll do it. Okay. Oh god. Okay, 1 minute. This is why I should not work on weekends. Okay. So what was the command you suggested, Sumant? Git push. Uh,
Git push origin and the branch name.
so now I am in the master branch. Okay. Not in the. I mean, I'm in the repository now, not in the branch.
Yeah, you can try this.
Okay.
Now we have to make these changes in the main, right?
Yeah. Code banks. Okay. No, man, it is still not. So this is for pushing code to the global repository. I mean, remote repository. Okay. For now, let forget about the branch. Okay. Um, I'll create another file here. Okay. Touch condition dot py. Okay. Um, vim condition dot py. I say insert mode x y z. Okay. So now I'm creating, forget about branch guys for sometimes. Okay, we'll get back to that, how to create
Yeah.
a branch. And because yesterday I was working on the branches and I forgot to switch to the repository, so the files and everything got created in the branch itself. So now what we have, uh, ls hyphen, sorry, ls hyphen a. So we have the condition py created on the repository. So git status, so this is there, git add condition. So now git status, so it is in staging environment. So from here we are going to commit, git commit hyphen m condition files on the local repo. Okay, one file has changed, three lines has been inserted here. So now we are going to um, push this. Okay, git push origin main. Come on. Yeah. So now this has got committed to the push to the remote repository. So now if you see, we are in the main branch, condition file is here. Okay, so now I am opening this condition file, xyz is added. What I'm going to do is I'm going to edit it, xyz 1 2 3. Okay, so commit the changes. So description, numeric value added. So commit directly to the main branch. I'm not going to use the pull request. Okay, I'm just going to commit it to the main branch. Okay, so now it got committed to the main branch. Going back to our, okay, here git, instead of push we are going to pull origin main. Okay, okay, so in the condition py, three lines has been added, one change, one file change, three insertion. Okay, now if you use cat condition.py, okay, xyz 123, so all the changes are being pulled from the remote repository to the local repository. All right guys, any questions on this?
No, sir. Good.
Okay,
No, sir.
okay, fine. So next we'll create a branch. Okay, now let's get into the concept branch. So branching is nothing but like we already seen it. So I don't want to make any changes in my working directory or working file. I want to make a copy of it and do the modification there. And after the validation, I will go and merge it with the repository. Okay, so for that, git branch um, hyphen c. So let's give it a name. Okay, let's give already created code banks. Now okay, let me give a cartoon name, cartoon character name, Dexter. Okay, who used to be a scientist, Dexter. Okay, so now uh, the branch Dexter has been created. Okay, so git branch hyphen a. So this will give you the number of branches that are available. So here you see code banks and Dexter are the branches here. Okay, code banks which I already created, Dexter which is created just now. Okay, so how will you switch from main to what branches? Okay, um, git switch Dexter. Now we are in the branch Dexter. Okay, ls hyphen a. So uh, what? So creating a branch that will exactly replicate whatever you have in the main branch. Okay, that is there. So how will we go out of this branch? There is one more command. Um, Git check out Dexter already on Dexter. Now let us go into code banks. Switch to branch. Our branch is up to date. Origin code banks. Okay. So um, there are two commands. Git switch Dexter. You are switching from main branch to the Dexter branch, main repository to the Dexter branch. And git checkout, you should give the name which you want to check out. So you are uh, navigated to the code banks from Dexter.
Any difference between this checkout and switch? Or it is same thing.
It is same thing, um, but the keywords is different. That's it.
Okay.
So git switch main, switch to main. Okay. So this is the minute of difference which we need to understand, switching between repository and branches,
Okay.
because we will be working on multiple things. Okay, so now let us see a couple of commands. Okay, git difference. Okay, so git diff. Mm, let me make some modification to the condition file xyz insert mode, um, abc. Okay, so when you make any modification to a file, okay, so I may not know what changes has been made. uh, right now we have only few files, so we are able to go into that and see what changes has been done. But here, um, like when we work on thousands of files, 10 maybe 10 thousands of files, okay, so we may not know what changes has been made to the files. So when you type git diff, okay, difference, so this will give you the difference between before and after. Okay, so condition.py, so it had what uh, one, two, three, which was the last changes has been made, and we added ABC this line to this particular file. So it will show the difference between um, before and after. Okay. So this is at your repository local machine stage. So after we add this to the staging environment, git add, so condition.py. Okay. So now our file is in staging environment. If you use the same, okay, same command, it will not work. So what you should do is hyphen catched. Okay, make sense, guys?
So can you just repeat it again?
Yeah. So see, I am a developer. So I generally I will be working on hundreds of files, not just one two files which we are showing it here. So we will be working on hundreds of files. So every time I cannot go and see which file has been modified and what content has been added, right? So when I use git diff, which is difference, it will show the recent changes made in the recent file.
Okay.
Okay. So what we did is we have had one, two, three already in this condition.py, and we just added ABC in that particular file, right? So by running this git difference, it showed me what changes has been made inside that file.
Okay.
Okay. So that is on the normal uh, directory where we are storing our file. Once the file is moved to the staging environment, you should add a additional option hyphen cached. Only then you will be able to see the difference. Okay, this is in the normal local repository. This is at the staging environment.
Okay, sir. Go ahead.
Okay, this command. So now what we have done is we moved this particular file, a condition file, to the staging environment. So I need to revert that. Okay. So my file now has gone to the staging environment. I need to revert those changes. Okay. So what I'm going to do is I'm going to use git restore hyphen staged file name condition.py. Okay. So now if I run the git status, it is not in the commit stage. Okay, it has reverted from the commit. Understood, guys? Change is not staged for commit.
Okay.
So tell me honestly, did you guys understood or I confused you or you got confused?
Understood, sir.
Yeah, this is a tricky one. Like I told before. So four stages: working directory, staging area, local repo, remote repo. Okay, working area is where we are having all these files now. Okay, so ls hyphen a. So this is my working repository, working area, sorry, working directory. Okay. So now git add condition.py. Now we have moved our file to the staging environment. Now the file is in staging environment, but now I figured it out. There is some uh, mistake in that particular file, or I want to add few more content to the file. So I don't want to commit those changes. So now what I will do, I need to revert it back. So for that, I'm using um, git restore hyphen stage condition py. If I do that, so my uh, the the file which I moved to staging will revert it back to the working directory. Got it? Makes sense? Okay. Okay. So now what if I am adding it to the condition.py? It is in staging environment. Now git commit hyphen m abc added to uh, condition. Okay. So now I have made the committed to the repository, local repository. So working directory, I moved it to staging. From staging, I committed to the local repository. Now I have to revert it. Okay. So now git revert. Okay. Hard file name condition.py. Okay. So the recent revert is recent changes. What we did is ABC added to the condition. Okay. So uh, it will show you the detailed thing what commitment, I mean what commit has been made. I'm going to quit. Okay. Now again I'm going to run this command. It will again show me reapply. Okay. WQ. Okay, now the file is not in the staging environment, I mean not in the local repository. It has moved back, reverted back. Okay. So main reapply abc added to the commission. One file has changed, two insertion has been made. Git log hyphen hyphen one line. So guys, this is the log timeline, not a timeline wise log but commit wise log. So if you see, we made a change. All the changes are being captured here. Okay. So what we did, we created a condition file uh, under main update condition py. Okay. Then we added abc to the condition file. Okay. And what we did, we um, okay, we committed that to our local repository. From our local repository we reverted it back. Okay. So that is filed as a, that has been created as another commit. From here again we reapplied abc added to the commit. So that has been captured as another commit here. So every commit has a commit id. Okay. So now I want to revert back to this particular commit id, so without creating another commit id here. Make sense,
Yes,
guys?
I got it.
Okay, you got
Yeah.
it right. So here you will use git reset hyphen hyphen hard the commit number. Okay, now we are going to reset to this 05a1 cbd. Okay, so this one starts with c, this is 0. Okay, head is now at 051. Okay. So now if you go and check the log, that the recent two commits are gone because we reset to the previous one. This is how you will roll back the changes if something goes wrong.
Okay.
Understood, guys?
So usually reset will not give you the commit ID.
Yeah, because we are resetting back to the previous commit.
Okay. And restore and revert will have the
We'll have the new commit in it.
commits. Okay. Got it.
Okay. Have you guys noted down the commands?
Oh, sure.
Prem is the GitHub master, so he will say. Okay, 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 guys. So now what we have learned most of the GitHub things. These are something which we need to learn. Uh, we learned this. So what you guys do is you guys practice it both Linux and Git. Okay. Um so do some more tests moving from what are like pushing the changes to the remote repository and pulling the request from remote repository to the local repository. Okay, so i'll I'll give you access to one other sheet. Okay, uh, I just noted it down in what for my reference, but you try all these things, okay, in your machine, and let me know. If you want to stay in the call, stay in the call and perform all these things. If you have any doubt, ask me, because once we remember or memorize all these commands and the Linux command and the present working directory, I kept on insisting you guys to remember the present working directory, but today I myself forgot and I was doing all the changes in the branches, not in the working directory. So that is fine, it happens sometimes. So that is why we need to be more cautious on the present working directory where we are doing the changes and modification, and how the path is, what is the absolute path. Okay,
Sure, sir. We'll practice once.
yeah, you practice this, we'll move forward and see what. So git repository versioning with git. uh, so versioning is what we saw right now. Okay, but we will look into this deeper again. Versioning,